Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson we're going to be talking about RAS mapper, specifically terrain modifications. So right here is a page from the RAS mapper user's manual. I'll leave a link to this page in the description of the video. All right, what I have on the screen now is my HEC RAS. Up at the top is my file GUI, and then down below here is my RAS mapper window. As you can tell, I already have some data added in, such as a terrain data, as well as rivers, the bank station, and the yellow cross-section lines. If the initial terrain model that you've downloaded and imported into your RAS mapper insufficiently represents elevation values, the ground surface, then HEC RAS provides tools for improving the terrain data directly in RAS mapper. All right, there's actually going to be two different methods I'll describe in this lesson. The first is using cross sections to create interpolated surfaces. That'll be actually in the geometric data editor. And then the second method is using terrain modifications within RAS mapper to create vector additions to the existing terrain data. Okay, so let's talk about the first method first, which I mentioned is cross sections used to create interpolated surfaces. The first few steps of this process I've already done and I've already covered in previous lessons. So those steps include number one, create geometry. Number two, start editing. Number three, four, and five is creating these lines you already see on the screen, which is the main channel, river center line, the red bank lines, and then the yellow cross sections. Step six is to stop editing and save the edits. So everything I just described, those steps 1 through 6, are already covered in my lesson 69, which is titled RAS Mapper, Rivers and Cross Sections, and I'll leave a link to that particular lesson in the description of this video. You can probably also find it in the playlist. Step 7 is to modify the cross section in the geometric data editor, which is over here. So I'll click on Edit Geometric Data. Now I've got my different cross sections showing up right here. Let's go ahead and check out this cross section that I have highlighted. So I'll click on cross section. This is 3363. That's the river station. All right, and here it is right here, 3363. And this can definitely use some cleanup if you're noticing that I've got hundreds of data points and I don't need that many data points, especially if I'm going to be making some changes. Okay, so let's go ahead and just filter out some of those data points first. I'm going to go up to Tools and then Cross Section Points Filter right here. I'm going to select 3363, which is the third of 5 cross sections I have here. And then I'm going to go ahead and just lower the tolerance on this collinear filter, and I'll use the near points filter instead. So I'll just start with these default values and then click on filter points. We start with 451. I want to get it down to below 100, but probably still more than 30 or 40. So let's just see what this does for us. Okay, it removed no points. Let's increase the tolerance. I'm just going to change this to 1 foot and then click on filter and see. Okay, so that removed 20 points out of 431. So let's just make it a much larger number here. And okay, restore, filter. Okay, so now we've removed a little bit more than half of the points. I'll change the 10 to a 50. I'm not sure if I'm doing this right. Restore, filter. Okay, there we go. So we have 56 points remaining, and we filtered out 392. So I'm going to click OK to accept those changes. And then let's go ahead and take a closer look at our cross section now. Okay, so I think this is better. So we're down to 56 data points, as you can see in the diagram right here. All right, let's go and now modify that cross section and modify some data points. So let me go back to the cross section and zoom in and just think about what change I'm going to make. So let's look at the main channel here. I only have like really 4 points or 6 or 7 points defining this main channel. So maybe what I want to do is add a few more points and then lower it. So right now the invert appears to be 94.05. What if I just go ahead and decrease that by a few feet? So maybe something closer to 91 feet. All right, so we'll go up to Tools. I'm going to use the Graphical Cross-Section Edit, and then right-click, zoom in on the main channel area. And then if I want to make edits, I can just go up to Options, Move Objects. So that's already selected for me. So all I have to do now is just drop these points. Okay, I can also add some points. So I'll go Options, Add Station Elevation Points. Maybe I want a new point there and a new point there, and I want to move it. So I'll go ahead and select Move. Then I can move it like that. Okay, so I'm going to go ahead and say that's good. Okay, I just realized I dropped it way too far. I should have been zoomed in more. I wanted to go from 94 to 91, but now the invert is probably 80, 81. You know what? This is just a learning experience. This is just a lesson. So let's go with it and see what happens. All right, so I'm going to go ahead and close that. I'm going to save the geometry. So File, Save Geometry Data. The next step is step 8 that it tells us to export the geometry to a new GeoTIFF file. I think I have to do that in RAS Mapper. Let's go back to RAS Mapper, right-click on the geometry file, which is base right here, and then Export Layer. Now what I'm going to do is click this top option to create terrain geotiff from the cross-section, both the overbank and the main channel. And then where I want to save this new TIFF file is going to be in my project terrain directory. And then I'm just going to call it modified terrain 2. And then click save. Okay, so the raster cell size, I believe this is in feet. I'll just go ahead and click 1 and click OK. And then let that file generate. Okay, so the file's been generated. The last step here is to create a new RAS terrain layer. So in the terrain label down here, I'll go right click, create new RAS terrain, and then I want to navigate to wherever I save that TIFF file that we just created. And it looks like it's right here under project terrain, modified terrain 2. Okay, no other changes need to take place. So I'll just click create and then wait a moment for that to come in place. I'll click close. And here is our terrain 2 right here. So as you see that the terrain that it created is only based on the extents of the cross sections and of course the main channel because I selected main channel and cross sections. So it's a much smaller condensed file and you can see that it uses the linear interpolation based on that cross section data, whereas the original terrain data right here looks totally different. All right, well that was the first of 2 ways to modify the terrain data in HEC RAS, in RAS Mapper. The other way involves using terrain modification tools. So we're going to make the terrain layer the active layer, which is this layer right down here. And I'm going to zoom in a little bit here. The first thing I want to do is create a clone of the terrain. Now I can do right click and add a new modification layer, shape, line, and polygon. This is what we're going to be talking about. But what I want to do first is sort of isolate my changes in case I don't want to adopt them into my main terrain, is to create this clone terrain layer. It says clone terrain virtual. So I'll go ahead and do that. I'll just give it a name. I'll say, yeah, terrain clone 1 is fine. I'll click OK. And now if I turn off my other terrain layers and turn on the terrain clone, it is a clone of the original terrain. However, the user manual mentions that it acts like a dependent in many ways to the main terrain file. So you don't want to delete the main terrain file and expect to be able to continue working and making edits in the clone. Wherever the clone goes, it depends on the parent, the terrain that it was copied from. Okay, so now I'm going to select clone, and now I'm going to go right click and add modification layer. Our options here are shapes, lines, and polygons. So whichever option we select, we have some sub options. For instance, with shapes, we can go with rectangles, triangles, elongated piers, ellipse, large woody debris, apparently. For lines, high ground and channel, polygons, multi-point, and rectangle. So let's go ahead and do a couple examples. I'll start with shapes. And the first example is going to be a rectangle. So I'll click on rectangle. I'll type out a name or just paste in a name. This is going to be called lower the main channel from river station 3363 to 3686, which are these 2 cross sections here. So I'll click OK, and then I'll zoom in right here. Now what it's doing is my cursor has a little dot on it, which is going to represent the center of that rectangle shape. So I'm going to go ahead and just place a dot right here, which is approximately centered between these 2 cross sections and also near the center of the river. What I get next is my dialog box to edit that rectangular editor data. I'm going to go ahead and call it a rectangle. And then for the name, I'll just call it the same thing, this river station range. For modification method, I have to specify either replace terrain, higher, lower, or add a value to terrain. These 4 options will be a little bit more easy to understand later in the lesson when I have a graphic to show what it's actually doing. But I'll describe it right now because this is where we're at. Replace terrain value. This is used to override the existing terrain values. Higher and lower value. These 2 are similar in concept, but sort of opposite in practice. What it does is, like for higher value, it evaluates the modification of the terrain and it uses the higher of the value between either the terrain and the user-defined elevation. Lower value is just the opposite. It uses the lower of the two values between the existing terrain and the user-specified value. And then the last one here is to add a value to the terrain. This is just to modify the value of the existing terrain. I'll go ahead and go with that. And then for elevation, I'll say 2, which means I'm adding 2 feet to the existing terrain within this rectangle here. The rectangle is really small at the moment, but that's all right because we're on the next step where we specify the length and width. It says length X and length Y. So the distance between these two cross sections is about 400 feet. I think it's a little bit less. So 400 feet should cover both of the cross sections. And then the width, I'll just say 100. And then the rotation angle, I'll say it's about 30 degrees. So I'll click apply and see what that looks like. Pretty good. The rotation is too much. So I'm going to change that to say 15 degrees. And okay, closer. Let's try 18 degrees. Apply. Okay, I'm happy with that. I probably could have positioned it a little bit further downstream, but that's all right. Okay, so I'll click apply and then click OK. Say, for instance, I have a bridge and we need to add piers. We can also use this simple shape modification to add piers. To do that, I'll right click on modifications, add modification, and then for shape, elongated pier is one of the options. For the name, I'm going to go ahead and type in or paste in River Station Pier. This is a river station number that's approximately between these two cross sections. So what I'm going to do is zoom in, and assuming we had like a bridge that crossed right here, and say that bridge has 4 piers, then I might have a pier 1, 2, 3, and 4. So I'm going to go ahead and just define a pier 1 right here, hence the name Pier 1. So River Station Pier 1. For the modification, I'm just going to go ahead and replace the terrain value with something abnormally large, like 1,000 feet, so that pier extends way up into the sky, and the water surface would never actually exceed the height of that pier. There may be situations where you need to be a little bit more specific with your pier elevation, but I'm just not going to be doing that. All right, the rotation angle, we know that is 18 degrees. And then the width of the pier, I'll say is 10 feet. And then down below here, we have some pier shape data. So if you watch the lesson on bridges and piers, we've seen a number of these parameters before. I'm not going to change any of them, except I think pier length would be a good one. So let's say maybe the bridge is 50 feet wide. So I'll just say 50 right there. And then a radius, actually width is 10. So if it's fully rounded, a radius of 5 would make sense. And then 5 right here. Okay, so I'll go ahead and click apply. And I noticed from the image down here, it's a little bit small, but I've got the rotation 90 degrees off. So I'll just add 90 degrees to what I have here. So 108, apply, and that looks good. Okay, so now what I have is my first of 4 piers. I'm going to go ahead and create a second pier right here. It's called Pier 2. That's fine. And then OK, Pier 3, OK, and Pier 4. So basically, the pier data that I set for the first pier sort of was saved and acted as a template for me to quickly just click, rename the next pier, and then click apply and OK. So that was 2 different ways to modify the terrain, but using the shape modification. The other 2 options for, hold on, let me go ahead and save this. So stop editing and yes. The other 2 options for using modifications within RAS Mapper, if I go right click, are lines and polygons. This shape method is considered a simple method with a single elevation. And then line and polygons are a little bit more involved because after you create the particular shape, you can also define control points. And then the final elevation is not only based on the shape, but the control points and an interpolated triangulated grid using those control points. All right, so for lines, let's move to a different location in the river here. Let's move down to between the downstream 2 most cross sections I have, which is 2778 and 3363. Line modifications are typically used to sketch along a center line of a road, like on top of a levee, or along an invert, which is like along the bottom of a channel. Elevation data is then applied to the line, where the start of the line is represented as station equals 0, and then the stationing increases as the line gets drawn in either the upstream or the downstream direction. In the case of a channel center line, the line will define the invert, and once the line is sketched and the elevation is defined, a simple trapezoidal template can be applied to that line for the cross section to define a modified terrain. So let's go ahead and give that a shot. I'm going to go right click on the modification, add modification, lines, and now I have the option between high ground and channel. So channel would be our invert, high ground would be off to the side of the main channel, such as a levee or some sort of embankment. But let's click on channel. And then for the name, I'm just going to go ahead and paste in what I have on my clipboard, channel invert from 2778 up to 3363, and then click OK. All right, let me zoom in a little further here and then just give a single left click to start the line. That's station 0. And then I'll give a couple more clicks, 2, and then my final click here for the 4th point will be just beyond this upstream cross section. This brings up our ground line editor box. So let's see, can I get this out of the way? Okay, not really. But anyway, right here, this is the line that we're editing the ground information for. We have a line right here, and then here's the modification that we saw before, but it's a little bit easier to understand. So check out this profile plot, this lower plot, as I change the option for the modification method. So replacing the terrain value, this will allow me to just type in the values in this lower table here to represent the magenta line, which will be the modified terrain. All right, the next down is higher. So this is going to take the higher of a straight line value or the terrain. So it's going to mimic the terrain here, but then it's going to be straight line here and then mimic the terrain here. If I click this right here. Okay. And then the opposite is true if I go with lower. So it's going to be lower. It's going to mimic the terrain. It's going to be lower. And then the last one here is adding a certain value to the terrain. I'm going to select higher. Also, with this table data down below here, we have a station from 0 to 355 feet. And I can add interior points to that. So we have 9178 goes up to 9242. Let me just go ahead and copy, paste, and then say I have 100 and 200 are some interior station points, and that is 91.8. And then after that, it goes up to 90. Let's go. How about 92.3? So to really get a glimpse of this exact data, I should probably change this to replace terrain values. And from here, you can see the 4 different data points. So 1, 2, 3, and 4. I'm looking at the magenta line here. However, with this particular data, I can then change the modification method to what I had it before at higher. So it's going to use the higher data or the user entered data. I'm going to go ahead and just go with user entered data so we can actually see some good results when we get to the end. All right, up in this top view, we have a cross-section view, and this geometry is that trapezoidal template that I mentioned earlier that's going to be applied along the length of the profile line. So if we wanted to make the bottom width different, like skinnier, such as 20, and then tab off, this display will update dynamically once we go ahead and enter a value and then tab off. So say, for instance, the right side slope was more shallow and not as steep. I could change that to like a 5-to-1 slope, tab off, and now we have this right here. Let me go ahead and change that back to a 2-to-1 slope. And then finally, this max extent width, this would refer to the top width for a channel and then the bottom width for a levee or center line of the road. If I wanted to make it much higher, I could just change it to 1,000. And then if I wanted to make it smaller, I could change it to something like, I don't know, 20. Oh, I can't do 20 because it can't really be less than the width. So let's go ahead and make it 40. So go ahead and check that out. Snapping tolerance, this distance here involves when we're going to be putting in control points, which is coming up in just a moment. So anyway, this is the distance to snap elevation control points to the ground line. All right, so let's go ahead and demonstrate that. So I'll click OK. And now you can see the modified terrain a little bit if I zoom in. So here's that trapezoidal channel shape. I probably should have made it wider. That's all right. It's time to demonstrate the control points now. So I'm going to toggle off some of the river lines. And then there's this plus button here that we didn't have before because we're using a line modification, so if I click plus, I have control points. And if I wanted to add control points, looks like I'm already editing, click on add. Here is the control points that I can go ahead and set down. And then that 50-foot distance, you see the little crosshairs that's on the control line, right? The modified line that I added. It disappears as soon as my my cursor is past that buffer region, which I believe was 50. Okay, so anyway, it's not too hard to hit the line. When you go ahead and click on the line, it's asking for an elevation, and it's going to start you off with the existing elevation. So if I actually want it to be a little bit lower, I would just type in a lower number here. Instead of 91.78, I might just say 91.7. Click OK. Add another control point further upstream. This would be 92.026. Maybe this is just 92. Okay. These control points would be good if you had actual real world data to base your future interpolation off of. I'm going to add one more at the top of this line, 92.40. Let's go ahead and increase this one a little bit. So I'll say 92.55 and then click OK. The elevation from the control points will be used to interpolate values along the line modification. All right, so I'm going to go ahead and click Save. Yes, let's go ahead and investigate this last modification type. Again, we're within the clone terrain. So I'll click on Modifications to select it. Right-click to open up the context menu. Click Add Modification, and then hover over Polygons. And then my options are multi-point line and rectangle. I'll go ahead and go with multi-point line. And actually, before I do that, I need to know where I am. So I'm going to toggle on the rivers once again, and then just advance up to the next pair of cross sections. So I'll just kind of do some work between these cross sections here. Going to collapse geometries, right click, add modification, polygons, and then let's go with multi-point. Rectangle just means you trace out a rectangle. Multi-point is a little bit more robust and flexible, where you can sketch out all the vertex points of a polygon. Okay, I'm going to go ahead and give that a name. Click OK, and then just single left clicks to start sketching out a polygon. Double click. For the name, I'll give it the river station range that we're working between. The modification method, we've seen this before. We could just add a value to the existing terrain, or replace, or higher, or lower. So I'll just go with add for now. The perimeter profile mode right here, we have three options. The first one is to use terrain elevation or control points to override. This is the default, and it matches the perimeter elevation along the perimeter, and then it's going to use the control points that I set within that perimeter to create the actual mesh, the actual modified terrain elevation values. The second option down here for perimeter profile mode is grayed out. That requires a shapefile for a Polygon Z type shapefile. I don't have that. And then the last one here is just to use a constant elevation along the perimeter, which is definitely not what I want to use since I'm crossing over the river for both bank lines here. Okay, the snapping tolerance is 20 feet. That's fine. I'll click apply and OK. Then what I want to do in this situation is start making edits to the control points. So I'll click on control points. It looks like I'm already editing. And say I know for the control point up here is a certain elevation. I'll type in that elevation. I'll click OK. Then maybe over here is a different elevation. I'll type in that elevation. I'll click OK. You need to do this enough times so that the triangulated network doesn't look all wonky and weird like it's starting to look with just 2 points. So perhaps the area that I sketch out should be a little bit more smaller and better defined before actually putting in the control points. All right, one last thing to mention is once the modifications for a clone has been created, you can copy those modifications to a different terrain. So say, for instance, we're happy with our modifications with the clone. What I could do is right-click on modifications, copy modifications to, and then select one of my other terrain layers. So I could select terrain 1, the original terrain, or this terrain 2. So if I click on the original terrain, right now there's no modifications, but if I click OK, now all the modifications have been copied over. So if I expand my terrain 1 here, let me toggle off the clone, toggle on terrain 1, and as you can see, I have all the modifications that we had just edited in. That's all there and saved. Just a quick way to make a clone and then copy those changes that we're happy with into our main terrain file. All right, well, that's it for this lesson. What we did was, let me stop the edits here, was to bring in a terrain layer, which was downloaded from online, and then make some modifications to that layer within HEC RAS, either by using cross-section data and the geometric data editor, or using the different tools within modifications, add modifications, either shapes, lines, or polygons.